What are the must-haves for AI banking solutions in 2022?
What are the organizational must-haves when it comes to implement AI machine learning strategy? Now, first of all, I would like to focus on organizational must-haves. As I mentioned and as I ended the earlier part, many people perceive AI as this magic. There are data, and banks have lots of data, and that AI is making a value of those data. However, it's not so simple as on this very short diagram, because machine learning is more sophisticated process and include different steps that need to be taken to bring the real value. One of the things is data, and as mentioned in the beginning, banks have a lot of data, and what's more important, very valuable data. Those data are concerning customer products, customer personal data, but also transaction. And from transaction, we can get very interesting insights when it comes to customer behavior and customer attributes. As example, I can mention that when we work only on transaction data of one banks, when it comes to customers, we were able to extract from transaction more than 130 different features of a customer, different characteristics of the customer. So it's also transaction is very valuable source of data, not only about spendings of the customers. So when we are talking about the data, firstly, we need to select the data that we should use, and it usually bases on business case which should be solved. So usually when we define business case, and then we talked which data should be used to address and to achieve a goal that is connected with this business use case that we want to address. Of course, we need to define what are the sources of those data, and usually those data are not in one system, and even data concerning transaction are in the card systems, in core banking, and other bank systems. Usually it depends on the bank. So we need to decide which data do we need, and from which source, the data are the most valuable. But also we need to look at the integration, because as I mentioned, there are some modern systems and we can easily integrate our Kafka or product APIs, but there are also valuable data in some legacy systems, and then more sophisticated methods of integration need to be put in place, like connectors like to database or even files connectors. What's getting the data? It's of course not the end, because we need to understand the data correctly. And at this stage, very important is cooperation between machine learning people, data people, and domain experts, because those data should be prepared in a proper ways. So usually as we get raw data, data scientists needs to look at those data, perform a raw data exploration, visualize data, and transform them to make it easy, make it possible to analyze those data and to use it for machine learning models. So it's usually done in this data engineering stage. Of course, data exploration is also a very important part of this AI ML process. And it means that data scientists are exploring features, need to find relations between those features, and make again necessary transformation. And in the end, finding some patterns which are hidden in those data. And just after this stage, it's possible to start the maybe not most important thing, but the most crucial thing, like data modeling. And it's also a kind of decision, because it can be, there are some methods connected with supervised learning, and we can use it, for example, for transaction classification, subscription management, detection of recurrent payments. This method, it's used in case when we know what can be achieved by a model. So we can classify the model. We can teach a model how to detect that particular transaction is connected with particular category. But there are also methods connected with unsupervised learning, like customer segmentation, because we cannot teach machine learning model, teach algorithms to which segment the customer should be assigned. So in this case, we are using different subset of features, and the machine learning model is responsible for assigning, for dividing customers into different groups. But we cannot train how to do it, and we cannot verify on those training data. Of course, there are several different methods, different models that can be used. So in the end, it's necessary to find which of the models that was used brings the highest quality. And it's not only about model accuracy, because there are different elements, and depending of business case, there are different metrics, analyzing true-false classification, and so on. So it's always part of the machine learning data, part of data science, to decide which metrics should be in line when it comes to model evaluation. And of course, model tuning. When we pick the most appropriate way to solve a particular problem, there is always still a lot of space to do additional experiments, to do additional training, to use additional features to improve the quality of the model. And preparing very good model with very high accuracy or other high parameters, it's not the end of the adventure with machine learning, because it's just the beginning. We need to keep the whole model in good condition, and to make the model will work also in the future and keep a very high quality. So MLOps process, like monitoring, automation of model tuning, is very important to put in place, and to make a model successful also in the future. Of course, we need to pay also a lot of attention when it comes to different legal constraints, because banks are working on sensitive data of the customers, things connected with transparency to avoid different biases and different elements. Especially as example, we can use, let's say, credit scoring, when the machine can, for example, discriminate some people because of some particular feature, some particular characteristics. An example we can use, maybe not from the banking, but I think the most popular example of bias, like Amazon in 2013, who wanted to use ML to support recruiting processes within the company, and they work on historical data. And the algorithm found that most of the employees then was men, so they were discriminating women, because the assumption was made wrongly by the model. So here is very high role also of data science and machine learning engineers to avoid such biases and avoid some mistakes made by the model. Now I focused on elements connected with data. However, also very important are infrastructure part and having data in appropriate database, enabling different analysis. And now I would like to pass voice to Alex, who represent ArangoDB, our partner. And Alex will tell you a little bit more about this database part.
Thank you, Michal. Yeah, so as Michal said, handling the data in the context of AI and machine learning is a fairly important, if not the spine of all this model. And there are a few technical must-have for AI banking solutions that you need to gather to make sure to have an appropriate solution. As Michal said, banks do have a lot of data coming from different sources, because they also have a huge history with IT. There are plenty of data source in different formats that needs to be handled to get some appropriate information. And at some point, you need to be able to handle these several formats, ingest the data in different ways, including different connectors, including different languages that might be involved. It could be some Java, some Python, some Node.js, some .NET, and so on. And because of this huge legacy of banking system, there's also a lot of data that need to be handled. And therefore, you need to have a really a system which is really capable of handling large volumes and being able to scale, because this data will not go anywhere, and it is called to grow with time because of the new different sources that will enrich the existing model. And most of this data, partly with new collections of data related to marketing, related to other source of information, will be unstructured in the end. And you need to have definitely a system that will be able to handle all this unstructured data with the best possible way. Therefore, you need also a good graph modelization, because nowadays we all know that relations between data is as important as the data itself. For several years, we have been considered data as just a set of tables that contain some information, but now we do realize with complexification of the system that the relations are as important as the data. And also because the aim is really to apply some machine learning techniques and some artificial intelligence on top of that. It is now admitted that prediction, leveraging relationships between these data is far more valuable than the prediction you can do just on the data itself. And definitely going through a graph to do some prediction, to do some detection of specific patterns, some communities, and things like that will be far more efficient within a graph model. But since we're talking about machine learning, there's no secret. I mean, good models that you're going to build comes from good data. And definitely your system has to be ready to prepare the data the way you want and to clean it, to transform it before processing it and putting it into a model. And basically this is what ArangoDB came in place here by providing different data structure that will be handled within its system, within a single source of truth. So it will be capable of handling different document models, different key value store, and will apply on that a graph model that will link all these documents all together. And of course, to simplify and have some consistency on top of that, there will be several functionalities that will help you leveraging this data, either by using some full text search that might be useful for pre-processing some data, but also graph processing algorithm that will help you building and discovering some specific patterns within your graph, as well as preparing your data with some graph ML and analytics pipeline based on ArangoML. Of course, the system, because as Michal said, there's a lot of different banks nowadays out there. There are fintech, there are traditional banks. The system needs to have different ways of deploying, guaranteeing security on top of that. And of course, you can definitely leverage that kind of database either as a full on-premise and full on-premise system that you're going to be able to run on a traditional platform or in a Kubernetes environment or OpenShift environment. but also as a managed service for those who are not reluctant with the cloud, still guaranteeing heavy security for that single source of data.